Hello learners, so in this particular session we will study about the classification aspect of R programming. So there are various classification and regression models that exist there. So there is classification as well as clustering. So we will see both of the things in R. In this particular session we will focus more about the classification. So we have already seen that there is certain aspect of the classification where you will be given something called a training data, and then we will be given a testing data. So what that means and what actually is it, before going into that I'll just tell you a little bit about the classification. So the classification part is very simple. Whatever you do, you have a category that is referred to as a class. So if there are multiple classes, so what you see, the colors are kind of a classes like red, green and blue. These are three classes of colors. Similarly, if you think like male and female, so what is this? This is again two classes of gender. Similarly, if you go in other aspects, you will find that there are different types. So you can consider the classification as dependent upon the types of category. So if there is only two categories, that will be referred to as a binary classification. So you can only divide the data into two categories, either 0 or 1. And if there are more than two categories, that is referred to as a multi-class classification. So three or 4 or 5 categories, like the type of flowers. There are different types of flower that comes under a particular category. So there the category can be more than 2. So if you take more than 2 category, that will come under your multi-class classification. So the classification algorithm has important problem. First is the classifier. So this is an algorithm that assigns input data to a specific category. Then the classification model is being prepared based on the data and whatever is the categorical value, and based on it you can simply prepare a model. In the end you can give the unseen data to the model, prepared model, and then you can simply predict either which class a particular feature or a particular thing is belonging to. Similarly, another thing is characteristic. So characteristic will be referred to as a features. This is individual measurable property of an observed event. Another is binary classification. So this is a classification task with only 2 outcomes. Another is multi-class classification. Another is multi-label classification also. So the multi-class classification is that whenever the classification is done in 2 or more classes. So the example of a multi-class classification is that digits. So there are 1 to 9 digits, 1 to 100 digits. So whatever you can whatever category that it represents. So if the digits is 1 to 4, so these are 4 different categories here. Similarly, multi-label classification. So this is a classification task where each symbol is assigned a set of target labels. So the example of a multi-label classification is that a news article that can be classified by multi-label classifier as people, places and sports at the same time. So a particular newspaper has people column, places column and sports column. So it can be multi-label, but it is a single entity. So that is referred to as a multi-label classification. Moving on forward, the type of classifiers are linear classifier. So there are 2 linear classifiers here. First is your logistic regression that we have already seen in the previous session. Another is very similar to this one is naive Bayes classifier. Okay. So moving on forward, the classifier, different type of classifier are support vector machine, decision tree and random forest. So support vector machine is one of the widely used classifier that have been used in many in all the languages. Like it is also the function is also being present in Python, C, C++. So it is widely used classifier. So this is one of the most efficient classifier that is being deployed here. So its main task is to just separate one class from another class using a hyperplane. So it will again come under a supervised learning algorithm that can analyze the data used for classification and regression analysis. In a particular SVM, each data element is represented as a value for each attribute. So you can think of it like a n-dimensional space with a value at each particular coordinate. Similarly, there is another one that is referred to as a decision tree. So a decision tree is a supervised, again it's a supervised algorithm that will create a tree of decisions, and it will certainly bring out the relationship between variables, but it also dependent upon the what are the decision that is taken by the algorithm and how those set of decision is affecting the result. Okay, so in R, decision tree classifier is implementing using the R machine learning Kulet package. You can use that, but there are other package like Caret package as well that is being there. So the random forest algorithm is also a part of this decision tree, but it is much more much more efficient than the decision tree, that the conditionals, that the most general decision tree that is referred to as a conditional decision tree. So it is a part of decision tree. So random forest is a kind of a decision tree, but is much more efficient than the general decision tree classifier. So we'll study deep the decision tree classifier and the random forest by using a simple data set. Okay, if I show you that firstly you have to install the package referred to as Caret, CARET. So another package that we install before continuing with the example is the Party package. So Party package will also contain a data set, but you can use this particular Party package, but there is another package that is inbuilt. For input data we will be using the inbuilt data, that is Iris data set in this. So the syntax is very simple. How you implement a decision tree, that is C tree more specifically. The function is very simple, that is C tree followed by a formula followed by the data, and the parameters here is C tree. The arguments here in this function C tree is formula comma data, and formula is again the predictor and response variable will be given towards the formula, and data will be the data set that we will be inputting inside it. Okay, so check here there are different types of decision tree that are present, but more specifically we will be only using the conditional decision tree. So there are other categories of decision tree, but there are many categories of decision tree, but all of them falls under two categories based on the target variable. First one is your continuous variable. So it refers to the variable whose target variables can choose value from a wide range of data types. It means that there are continuous values that is being present in the target variable. Then there is categorical variable. So in this particular variable, what we are doing, the target value will be set, it will be belong to a particular class. So it is more belonging that a particular target variable has definite set of values, like it has only 2 values. So there are 2 classes. So if it has 3 values, it has only 3 classes. So it means that there are 3 classes. What it means is that the feature or a particular input will belong to either of these 3 classes. So 3 groups can be formed based on that. Okay. So one more thing I want to tell you about the trees is that it is a supervised learning technique. So supervised learning means that it is presented first with the data as well as the result. Okay. So it is presented with the data as well as the result, so that it will be able to generate some rules based on which it can predict well. So what do I mean by this is that Supervised learning is that you will be provided with the data and with the result. Unsupervised learning is that you are not provided with the result. So you are not supervised here. There is no one present to train you. You are just looking at the data and you are learning the data itself without looking at the result. But a supervised learning is that you are provided with the features as well as with the result. It means that if a particular thing, if a particular input belongs to a class 1, so you will be provided that sample, and you will be also provided with the result, that is class 1. Similarly, if there are 100 samples, if you are provided 50 samples, so 50 samples with the result, that is which particular class a particular sample belongs to. So this is referred to as your supervised learning. Okay. So similarly, for unsupervised learning, you will be only provided with the data. You will be told that there are 3 classes, and based on the data, you will be dividing that data into groups. So this is as simple as that. Okay. So moving on forward, so what is the input data we are taking here? We are only taking the library caret. So if you have installed party library, that is also fine, but we will be only using the library caret. Okay, so firstly import the library that is being installed first. So for installation, go to the tools part, and in the tools you go to the package part. By clicking on the tools, go to package, and then you can write here caret. If you do not want to do that, you can do it with the help of only console. So on the console, go to the console, write install.packages, in the double quotes write the name of the package, that is caret. Okay, so it will take a little bit of time to install all the libraries into it. So when it is installed, the main thing that many forget is not that they will not import that library. So write library, in the argument write caret. It means all the functions of the caret has been imported in the workspace. So another thing is we are taking the iris dataset. In the iris dataset, this is a dataset of different species of flowers where you are given with sepal length, sepal width, petal length and petal width. Based on that particular thing, you are predicting that this is a species of a particular flower. So based on that, you will be predicting that which particular category of flower it belongs to. So the category are 3. There are 3 types of categories here. First is Setosa, another one is versicolor, another one is virginica. So these are 3 different categories of the flower. Okay, so now you have seen what is the data here. So we have only printed the head of the data, that is only 6 sample that it is showing, with the sepal length, sepal width, petal length and petal width, and with the result as well. So again, because this is a supervised learning, so we will be dividing this particular data into training and testing part. So if you see here, you will set the seed to any number. You can set the seed to any number so that the classification will always be same. So what we are doing is we are taking the indexes and we are creating a data partition. So data partition based on the iris species, and p value here is set to 0.9. So what it means is that 90% of the data will be taken for training and the remaining 10% of the data will be taken for testing. So it means that supervised learning will be performed on 90% of the data, and for evaluating that your model is good or not, it is able to predict well or not, you will be taking the testing part. Okay, so now there is a train. What you're doing here in the next particular line is that you are taking the indexes from the create partition part, and you are storing this into the train. So train variable will contain 90% of the sample for training, and test variable will contain the remaining 10% of the sample. So that is why it is written as not indexes. So this is a symbol of relationship we have already used, but here it represent not indices. So what it means is that whatever indices is stored in the variable indexes, so apart from that indexes, all the indexes will be stored in the test data. So 90% of sample, if there are 100 sample, 90 samples are stored in the train variable, 10 sample is stored in the test variable. So now the conditional tree, C tree will be used. The formula is very simple. So T model, C tree, and now in the formula what we are writing here. So check here from left to right, from right to left. So we have written data equal to train. So what it means is that we want to make a conditional tree on the data which is train data, that is 90% of the data, and the relationship where we want to figure out is the species relationship. So write species followed by a not sign. So when you print the T model, what will happen? It will tell you that how the model is being prepared, what are the values, what are the criterias are being set, what are the observation that is being given by the conditional inference tree. Okay, so if you print the T model, it will tell you that it has made 4 terminal nodes, and the conditional inference tree with 4 inference node is being there, and it has made 135 observations. So the number of observation meaning the total number of samples were 135. So for every particular decision node, it will tell you what will be the criteria, what will be the statistic, and either what is the petal length, it should be greater or less than. Okay, so you will not understand much from here. When you draw or plot the T model, you will understand more. So in the next one, I have simply written plot T model, and then it will show you the T model part here. So it will draw the model. So if you check here, it is starting from petal length where P is less than equal to 0.001. So the significance is very less than as compared to 0.005. So it is saying that now it is dependent upon the value petal length. So if the petal length is greater than 1, and if the petal length is less than or equal to 1.9, it will say that it belongs to a flower named Setosa. If it is greater than 1, so this is how the decision tree is made. Then another variable that have to be considered is your petal width. Now if the petal length is less than or equal to 0.9, so the category of the flower is Setosa. But if it is greater than 1.9, if it is greater than 1.9, so it will check for petal width. Again, if the petal width is greater than 1.7, then the flower is again Setosa, and if it is less than equal to 1.7, then it will again check for petal length. So similarly, it is setting which particular flower it belongs to. So there are 3 category of flowers. So for every one, so it is dependent upon it that if petal length is something like this, then this particular flower is 100% accuracy, it is saying that it is Setosa. If you check that what is the inference that is given here, so if you check that petal length is less than equal to 1.9, the criteria is 1. So it says it is 100% sure if the petal length is 1.9 that this particular species of flower belong to a particular category. Similarly, another inference is given as if the petal length is more than 1.9, then it will go for the petal width, and if it is less than 1.7, then the criteria will again is 100%. Similarly, if it is not, then it will again go for the petal length. So this is how the decision tree is being built and how the weights are being set. Okay, so if you want to predict this, the prediction can also be done because we have only draw the diagram here based on the training data. So we have only done the training, and based on the training it is able to draw a model based on it. Now if you want to predict, so you can also predict the data na? So when you enter the testing part here, so when you enter the testing, you can simply take the testing data and you can give the testing data to the prepared model. So how to give it? So simply write pred is a variable name equal to predict t model comma test. So test is all the variables, all the features of the sepal, the petal length, petal width, some with all the features of the flowers that is being there without the actual species. So the species will not be given to the predict variable or t model. So that model has to predict based on only the features of the flower. Okay. So another thing is that you can also print the confusion matrix. So after in the prediction model, the result will be stored and you can simply build a confusion matrix based on it. So in the pred variable is the predicted values that is being predicted by the t model, and in the species test dollar species column, there will be your original values or the ground truth values. So you can simply build a confusion matrix based on it. So if you check here, confusion matrix is formed in such a way: Setosa, versicolor and virginica. So it is written in the column and row. So what it means is that Setosa 5 5. So out of 5 it has predicted 5 as Setosa. So 100% accuracy here. So out of versicolor it has predicted 5. So there are total 5 versicolor and it has predicted 5 out of 5 that these are versicolor. Similarly for virginica, it has again simply predicted 5 out of 5 that it is virginica. So if you check here, the overall accuracy is 100%. Overall accuracy is 100%, and the kappa value and McNair test value, that is not applicable in this case. So you can also, because it is a confusion matrix, so another appropriate measures can also be printed, because if you check here, the overall accuracy for the model is 100%. So you can also print sensitivity, specificity, prevalence, detection rate, detection prevalence by simply by just printing the confusion matrix. So confusion matrix will also give you these kinds of measure, not only the confusion matrix but also other types of measure which we are also dependent upon. So sensitivity, specificity is also one of the most important measures that we use in checking the accuracy of the model. So this is how a simple example of a classification by decision tree, that is more of a conditional a decision tree. So if you want to go a little bit further, there is something called a random forest. So this is again a type of a decision tree, but it is more accurate than the decision tree because it uses something called feature importance. So what do I mean by this is that it will assign certain index to a particular feature. I'll show you with an example how. So it will assign certain value to a particular feature, saying that this particular feature is much more important than the other one. So based on the feature, it is saying you make the decision. So the classifier makes the decision based on the feature. So random forests are nothing but are a set of decision tree that are used in machine supervised learning algorithm for classification and regression analysis. So random forest not only can be used in classification, but they can also use be regression part also. But primarily they are primarily preferred for classification. The classification algorithm that is being used here is non-linear. To achieve more accurate prediction and forecast, random forest creates and combines numerous decision trees together. So this is not one tree, but there are many number of trees that are combined together to form a random forest. So that is why the combination of tree is referred to as a forest. So however, when utilized alone, each decision tree model is used. In the case where tree is not built, error estimation is performed. This method is also referred to as out of bag percent error estimation. So this is one of the features of random forest, that it uses out of bag percent error estimation. Okay, so moving on forward, I'll take the same example here. The example is very simple. The algorithm is very simple itself. The steps of the algorithm is you just draw, bootstrap random samples, means you just randomly select the sample from the training data, and then you build a decision tree from the bootstrap sample. So bootstrap sample will be that the samples that you have selected from the training data, and then randomly select features on each tree node. Similarly, you split the node using a feature, the feature importance part, that provides the best split according to the objective function. And then one such example will be to maximize the information gain. And now you have to just repeat the first two steps to perform this k number of times. Now where the k number represents the number of trees that you will create from the subset of samples. Okay, so in the end you just aggregate the prediction from each tree and you combine and you give the result. So this is how random forest will work. So let me see that to perform this, you just have to install the packages. So the package is simply referred to as random forest. You write random forest, install the package, install.package random forest, and again we will be using the same library iris dataset for this as well. So the parameters here is, the argument here is formula and data, which is very similar to the previous example. So the input data here, again we will use the iris data. Now here I have taken the data and I have divided the data into 70% training. The p here represent 0.7, so it is 70% training and 30% testing. Okay, so it means it requires it. In this particular example, it has less data for training as compared to the conditional tree example. Okay, so now check how this particularly will affect the model or the accuracy. So you just simply write random forest formula equal to species not sign and then data, which is the data we are using, train, and importance set to true. So this is feature importance that is being set to true. So always use this feature to enhance the efficiency of this particular model. So when you print the T model, it will again tell you that what are the number of trees that is being built. So in this particular instant, the 500 number of trees are being built. So the number of variables that are being tried at each split is 2. So again the error rate estimation is also given. Then we have also prepared a confusion matrix with class error as well. So you can see here there is a little bit of error in versicolor and virginica class. So there is no error in Setosa class. It is able to predict 35 out of 35, but here in versicolor it has predicted 33 as versicolor, which is correct, and 2 as virginica, which was versicolor. So this is where the error lies. Similarly for virginica, it has predicted 32 virginica, which is correct, but those 3 which are virginica, but it is predicted as versicolor. So this is how the confusion matrix is telling you that virginica was actually 32 that is predicted by the random forest, and 3 out of 3 that is supposed to be virginica is termed as or classified as versicolor. So that is the error in here. Okay, so again you can also check the feature importance part of it. So you just write important round, then write importance T model. Okay, so it will give you the Gini index, which is the most important feature in the decreasing order. So mean decrease Gini. So this is Gini index. Sepal length has a Gini index of 7. Sepal width has a Gini index of 2. Petal length has a Gini index of 28 and petal width has a Gini index of 33. So this can also give you the feature importance in case of random forest. So this is why it is much more efficient than the previous one. If you see here, previous one however is able to generate much more accuracy as compared to this one, but because the training data is being less as compared to the previous one. So confusion matrix, keep that in mind. I'm again showing you, this is an example of a confusion matrix. So at the row side you will be always written as actual class, and the predicted side will also be written on the column class. Okay, so wherever the yes and yes is written, so this is referred to as a true positive. So this is referred to as TP. So what it means is that if a particular class belongs to a particular it is predicted, there are 30 samples that belongs to class 1, and your classifier has predicted 30 samples out of 30 that it belongs to class 1. So there will be a true positive value of 30. Okay, similarly if any other leftover is being there, suppose there are 30 samples out of which 29 is predicted as class 1 and 1 sample is being predicted as class 2. So now this particular one will becomes the false negative. Okay, similarly for no class as well, the false positive and true negative. So number of actual negative cases that are correctly predicted as negative is referred to as true negative, and number of actual negative cases that are incorrectly predicted as positive, that is referred to as false positive. So the prediction part here, so you can also predict the same thing. You can just write predict model and you can give the prepared model to the testing data to the prepared model. So it will again print the confusion matrix, and you can check here. Now this confusion matrix is different than the previous one because that confusion matrix was for training. Here we are printing the confusion matrix for testing. So the prepared model is not able to 100% accurately tell you the result here. So it has been provided a sample. In case of versicolor, it is doing a misclassification of one sample. So out of 15 sample, it is given the 15 sample given to the particular classifier that is being trained. 14 was predicted right, that contains a versicolor class, but one sample that is also belonging to the versicolor class has given a label Virginica. That is wrong. Similarly for Virginica as well, Virginica out of 14, 15 out of 14 is correct, 1 is incorrect, and it is classified as versicolor. So that is why the accuracy decreases to 95%, and based on that you can check another matrices like sensitivity, specificity, detection rate and other things as well. So you can check from here that what will be the conclusion here. So the mean decrease accuracy expresses how much accuracy a model loses excluding each variable, and mean decrease Gini tells how each variable contributes to the homogeneity of the nodes. So it means the mean decrease Gini index will tell you the feature importance. So from the random we can conclude that you can see that we have built a random tree, and based on the random tree we are able to get 95% accuracy, that is overall accuracy. So in this particular session ends here. In the next session we will study more about clustering and then move on with the association rule mining. Thank you.